Hi everyone, and welcome to the third of 3 videos looking at some past exam questions on the topic of ionic bonding. In this first question, it's telling us about calcium phosphide, and it's asking us to write the equation for the reaction of calcium with phosphorus to make calcium phosphide. So we're going to start off with calcium. It's given us the formula of phosphorus. It's not one that's commonly known, but phosphorus as the element has the formula P4. So read the question, they're giving you some information here. And it's also going to make calcium phosphide, they've given us that as well. So then all we need to do is make sure this is balanced. If I've got 4 phosphorus here and I've only got 2 there, then what I'm going to have to do is multiply this by 2 to make sure it's balanced. And then what I've got now is a total of 6 atoms of calcium. So I'm going to have to go and put a 6 here. Okay. Then it wants us to draw a dot and cross diagram for calcium phosphide. Again, it only wants us to show the outer electrons. So if we look for calcium on the periodic table, calcium is here in group 2. So if it's got 2 in its outer shell, it's going to lose those 2 electrons and it's going to make an ion that's got a 2+ charge. So calcium is going to lose 2 electrons. It's now not got any in its outer shell and it's going to have a charge of 2+. And phosphorus, if we find phosphorus on the periodic table, phosphorus is over here in group 5, so it's going to have 5 in its outer shell. It's going to want to gain 3 electrons. So let's draw it with 5 in its outer shell, and it wants to gain 3, and it's therefore going to have a charge of 3-. These two don't balance out. We already know what the formula is because we've got it here. We need to have 3 calciums and 2 phosphorus. Okay. And this is usually acceptable. They will allow you to do this. If you want to be completely safe, you can just draw this out 3 times and just draw that out twice. But you will get the mark for doing it like that. Okay, moving on. In this question it says, fluorine reacts with aqueous sodium hydroxide to form F2O. 2 other products are also formed. One is an ionic compound with a relative formula mass of 42. Construct a balanced equation. Okay, so we've just got to write an equation for what's going on here. So what have they told us? They've said fluorine reacts with aqueous sodium hydroxide. So fluorine, we know, is diatomic. It's going to be F2. Sodium hydroxide is NaOH. And it's going to make F2O. And it's going to make 2 other products, so plus something else. One of these is an ionic compound with a relative formula mass of 42. Right, so looking at what we've got here, we know that in our 2 products, we're going to have sodium somewhere because we haven't used the sodium from the reactants. And we're also going to have hydrogen somewhere because equally we haven't used the hydrogen from the reactants. So the sodium must be in the ionic compound. Yeah, an ionic compound is a metal and a non-metal. Sodium is the only metal that we've got here. So what's it going to be? Well, it could be sodium oxide, it could be sodium fluoride. If it's got a relative formula mass of 42, let's find sodium. Sodium's relative atomic mass is 23. So if we take that away from the 42, it leaves us with 19. 19 is the relative atomic mass of fluorine. Okay, so the ionic compound with a formula mass of 42 is sodium fluoride. What does that leave us then as the other product? Well, we still haven't used the hydrogen, so hydrogen is going to have to be in this other product. The most common thing that this is likely to be is it's going to be water. Okay, that's the most likely compound that's got hydrogen in it. It could be hydrogen gas, but there aren't that many reactions that make hydrogen gas. There's much more reactions that make water. Let's just make sure we can balance this equation. If this equation balances fairly easily, it's a good showing that we've got it right. If it's awkward to balance and we end up having to end up with, 6s and 8s and 9s and something, it means we might have got our products wrong. So let's have a look. We've got 2 fluorines and 2 fluorines. Oh, I've got a fluorine here. So I've got 3 fluorines on this side. So I'm going to have 2 there to make it 4 fluorines. Then what I can do is put a 2 here. That gives me 4 fluorines and 4 fluorines. Also gives me 2 sodiums, so I'm going to put a 2 here. That's given me 2 hydrogens, which balances the 2 hydrogens there, so that's good. And then I've got 2 oxygens to balance the 2 oxygens. Okay, so that's balanced fairly easily, which suggests that we've got the products right. Finally, this question is asking us about barium. It's saying it blackens when it's exposed to air. This is due to formation of barium oxide and barium nitride. Nitride ion is N3-. Okay, it's nice of them to tell us that. What is the formula of barium oxide? Well, if barium is from group 2, oxygen's from group 6, so they're just going to bond together quite nice. It's just going to be BaO, because barium ion is going to be 2+, the oxide ion is 2-, isn't it? Barium nitride, well, if we're going to have barium as the 2+ ion and nitride as 3-, the way we're going to make this work is to swap the numbers over, and it's going to be Ba3N2.